Hello, I'm Roy Ruddle, and this video describes the 6-step data quality method. We have designed the method to let you investigate the quality of your data efficiently, rigorously, and reproducibly. The method is freely available, and you can download it from this GitHub link. Now, I've been working in data quality for more than 10 years, and that includes hands-on experience of large datasets about everything from people shopping and hospital patients to radio astronomy and even train doors. As well as that, we've gathered input from data scientists and analysts working in more than 15 industry domains, and together created the 6-step data quality method. In this video, I'm going to tell you what motivated us, outline the what, when, how, and why of the method, and finish by pointing you to 4 ways you can learn more. This is what people think data science projects look like in terms of the timeline. A small amount of time discovering, wrangling, and dealing with data quality issues. The vast majority of time doing the modeling and analysis, which is the main purpose of the project, followed up by some reporting. But reality is different, as anybody who has worked as a data scientist or analyst knows. Discovery, wrangling, and data quality often take more than half the time of the project, squeezing what's available for the rest. The key question is, why does data preparation take so long? Referring to the data quality part, one reason is it's not easy. Another is that most data scientists and analysts have little training in data quality. As a result, they do the best they can, but they tend to follow ad hoc, undocumented processes, and only a few checks are universally performed. Now, we've surveyed and talked to dozens of data scientists. A lot of them say that they regret not doing more, and they'd love to change that. What they want is 2 things. They want to know what constitutes good practice, and they want a rule book or process to follow. That led to this 6-step data quality method, and in the remainder of this video, I'm going to outline the what, when, how, and why. Starting with the what, 2 key issues are there's little information on good practice and norms, and on top of that, some data quality terminology is very opaque. We changed that using our experience and reviewing the literature to identify more than 60 characterization and data quality tasks. And in addition, we put a lot of effort into describing them in plain English, with each task articulated as 1 or more questions to answer about your data. Here are 4 of those tasks and their questions. Missing values is self-explanatory. One obvious question is how many values are missing for a given variable. But another question that you may not have thought of is, did you expect the variable to be complete? This gives us the first big benefit of the method. By documenting the tasks and questions, you now know what to do. And because of that, you should be able to do more in less time. However, as I said, there are more than 60 tasks. If we gave you them all together, like this, then you would be overwhelmed. Well, we've thought about that. By applying 2 principles of detecting major issues early and cleaning data on the fly, we have grouped the data quality checks into a carefully thought out order that has 6 steps. The steps go from bottom left to top right. The purpose of the first step is to check whether anything is obviously wrong, and one key task is to look at example values of each of the variables. The second step is to check for special values, which have been coded to indicate the data is known to be missing, invalid, and so forth, and to deal with them, for example, by setting them to null. Only when you have done that are you able to tackle step 3, which is to find out whether any data is missing, and that also includes coverage and granularity. Assuming all is well, You then move on to the next two steps, which are the biggest. In step 4, you check each individual variable. And in step 5, you check combinations of variable for business rules, functional dependencies, and assumptions. And a key lesson here is never assume, always check. You should be cleaning the data as you progress, and then in the final step, you profile that data, because that is what you will use in your modeling and analysis. However, at any point, you might find out something which sends you back to the beginning. A little bit like a game of snakes and ladders. The steps provide two more big benefits. By grouping the tasks into a logical order, the method helps you find out as soon as possible if something will stop you in your tracks. That will help you avoid rework, which in turn should reduce cost. And there are 3 ways in which the steps could help you improve your results. All of the steps will help you understand any limitations in the data. Step 5 in particular will help you correct any misheld assumptions. And the cleaning that you do in steps 1 to 5 will help you improve your data both for this project and as a future investment. So what about how? The short answer is use a variety of computations and visualizations. To find out the details, start by watching the other 6 YouTube videos in this series. What next? Well, here are 4 things you can do to learn more. Those 6 videos walk you through practical examples of the steps. I also recommend that you download and read the method. It's only 8 pages. Each step contains specific tasks that will help you identify whether there are any issues with your data and to remedy them as early as possible. If you use Python, then have a look at the Viz Data Quality package, because that includes the Jupyter notebooks that I use in the practical examples of the videos, so you can run and customize them yourself. And lastly, why not sign up for one of the workshops and courses that I run? You'll get hands-on practice with some data challenges. Once again, if you'd like to download the method, you can do so freely from this GitHub link. If you have any questions, then do feel free to contact me. Thank you.